You said that the final will just pretty much be like from the questions from the last tests?
Yeah.
Okay.
Yeah. I mean, not those questions, but
Pretty similar.
similar, yeah.
So the best thing to study is just the past tests.
Yeah, at a minimum. I mean, yeah, do those and then venture out from those if you can.
Mm-hmm.
Like, yeah. For example, if one of the past tests has a question about comparing two proportions, and let's say it's a left-tailed test, well then do comparing two proportions left-tailed, find one left-tailed, one greater than, find one left-tailed, one right-tailed, and one two-tailed. You know what I mean? But just know that there's going to be a comparing two proportions possibly, since that was on a test, you know?
Mm-hmm.
But maybe don't just study that one question, but at least study that one question. And you'll know the general ideas if you study that one question. But if you want to like do even more, you can branch out from that one question and maybe try to do one of each of the three different kinds, you know? But at a minimum, just study those questions. It's like, have you guys started studying yet or what?
Yeah, I like printed all the past tests out just to look at all the questions and see what I struggled with the most. That's kind of my idea to start studying for it.
I also,
Okay.
I was just gonna say, I found it helpful to go back in the homework and like all of the grades that weren't 100 yet, if they were at like 85 or an 89 or something, just go back and fix those, and then that helped refresh my memory on like the first two tests because I didn't really remember much from that.
Yeah, let's look at that test and maybe like test 2.
Here it is. All right. So which one you want to do? You guys will. Number 1, what about these? Describe the shape of the distribution. This one is right skewed. This one is what? Symmetric?
Yeah, or
this one is left skewed. This one is what? This is like bimodal. But don't worry about that one. Okay, here, this is a good one. This is like grouped data. It goes 25 to 34, 35 to 44, right?
Mm-hmm.
So how would you do this one? Do you guys know?
Couldn't you just plug it into your list on the calculator and do 1 var stats?
Yeah, well, hold on. Not quite. Be careful, because this is grouped data. Grouped data. This is not regular data.
Oh.
Right?
Yeah.
So do you know how to handle grouped data?
I'm trying to remember. You have to put it in, no, not like different lists. Or you just have to do it by hand somehow?
You can put it in different lists. That was right. So what you want to do is you want to take the midpoints of age, put that in L1, and then you take these frequencies and you put that in L2. So and the reason is, yeah.
Okay.
Yeah.
And then you would use.
But yeah, so you got to get the midpoint of the age, because if you look at the data, one thing that stands out to me is that between 35 and 44, I'm looking at the 4 different sections, the 4 age groups. And the biggest age group would be 35 to 44, right? Because that one has the biggest number at 37.1. So that's like the gravitational spot. That's like the center of gravity.
Yeah.
Center of gravity. So the mean should be somewhere near 37 because of that. Kind of gravitate around 37. So if you plug in the medians in L1 and the frequencies in L2, by frequencies I mean the millions, the numbers in millions, like 26.8, 37.1. 32.3 and 28.5. If I put those numbers in L2 and I put the age in L1, the midpoint of the age, I should be good to go. How can I do this on here without a computer, without a calculator? Let me try this. Let me try to go where no man has gone before. It's kind of weird with this big old thing. What's the midpoint between 25 and 35? 30?
Yeah, wouldn't it be 30? Yeah.
I'm going to use Excel because that's since I don't have a calculator here. 35, so 40 would be a midpoint. And then what, 50 and 60? And then what are these, 26.8? I hope Excel works. Like I hope there's a way to calculate this easily. 26.8, 37.1. We're also going to learn Excel today, everybody. 32.3, and you can do it on your calculator, it doesn't matter. 28.5. So what's the mean? The mean equals to that times that. Hey, what happened? Can I do Control Z on Excel? Yeah. So this equals to that times that plus, right? That times that plus that times that. You just multiply, right? Plus that times that. Or you could just put them in L1 and L2 and just have a day. But wait, what's going on? Why is it? Do I need to divide by something to get the mean? Probably.
Yeah, because I got a different mean on my calculator, but that's the, I don't know what it's called, but it's like an E and then an X.
Yeah. You got the sum of the X. That mean is not right. 56, the mean needs to be somewhere near 37. Like 37.
Yeah,
mean is 45.01.
That's better, right? Did you get that too, Jack?
Yeah, I got 45.
If I divide this, if I do this, oh wait, how come I get the sum?
Would it be divided by all the frequencies added together again?
Yeah. It's divided by the sum of what? The frequencies, right?
Mhm.
That should give it, right? 45.012?
Yeah.
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 Or you can just put them in L1 and L2 and then just do one bar stats, L1 comma L2, right? You can do that too. Nobody else emailed me, I don't think, to join this group. Let me check. I don't think I see any emails. No, I don't see any. All right, so what else? So that's how you do that one, right? Just get, like I said, get the midpoints. Those are the midpoints. Oh, there you go. And these are the frequencies. What else you want to do? So that's a good one to do. Number 3 is like says to draw a stem and leaf plot. Do you know how to draw a stem and leaf plot?
Yeah.
They give you data like this.
Yeah.
Put it in order. You put 7, 8, 9, 10 on the left because the smallest number is like 7. Well, I could open this in Excel, but yeah. And then the 1, 3, 5 means that you have a number 7.1.
7.3, 7.5.
Yeah. So that's kind of you have to round this to the 10th place. So 7.07, you have to consider it to be 7.1. So you put the 1 here.
You can't put decimals in the stem and leaf plot, so we always round it.
Yeah.
Okay.
Exactly. So 7, this thing is the definition. 7, 0 represents 7.0. So that's how you do that one. Do you want to talk about that more or no?
No, I think I got that pretty easily.
All right. And I don't like how they draw this centered in the center.
Yeah.
It should be left justified, you know, not centered.
It looks to scale, yeah.
Yeah. And then let's see, what else is there in this test? Define statistics. I don't know. I have the answers there. Should I get rid of the answers or is that okay? I could print this where you don't see the answers, but they're saying statistics is the science of collecting, organizing, summarizing, and analyzing information to draw a conclusion and answer questions. In addition, statistics is about providing a measure of confidence in any conclusion. So that's like a definition of statistics.
Yeah, I think I
Here,
remember.
C, it says statistics encompasses all scientific disciplines in which random occurrences are analyzed. In addition, statistics references any random occurrence which is reported using percentages or proportions. Kind of looks, it's not, I mean, the A through C kind of seem okay, you know, but D is
Yeah.
like more comprehensive. So, and this one, I made a video of this, one of my most popular videos. And basically, you're trying to match like these summary statistics here. You have 4 summary statistics, 1, 2, 3, and 4, and you're trying to match it with the histogram called, yeah, so yeah. And in these 4 sets of summaries, one of them is 65, 65, and the other 3 are 59, 59. And that tells us that that would be the first thing that we should look out, say, which one is 2? Which one is like different than the others? Which one is centered at 65? Like this one seems to be centered around here, 59, right in the middle somewhere. This one seems to be centered like right here somewhere, like 59. This one seems to be centered around here, 59. So this one down here has to be the answer because it's centered like here, which would 65. So that kind of helps us. So then, so what does that tell us? D is, so then 2, we would say D. So this one is D. Number 2 is D. And now the next thing you would look at would be 1.7 and 18. Those are the smallest standard deviation and biggest standard deviation. So those are the extremes. We want to look at the extremes.
So one should be like
that,
super spaced out.
Yeah, like this one goes 54 to 64. That's a range of 10.
Pretty small.
That's a small range. This one goes from -1 to 119. That's a range of 120. That's pretty huge, right? So these might be them. And then this one goes 29 to 89. That's a range of 70. So 10, 120, and 70. So the top 2 would be,
they've got to be
the most compact and the most spread out, right?
Mm-hmm.
So then we're done, right? Based off of that. Yeah. And then what else? 6 says, what does 6 say? It's talking about like mean, median, and mode, right? So it just gives you a bunch of data, and it says find the mean, median, and mode from a given set of data. Plug the data into L1.
pretty standard.
Just do one of our stats, right?
Yeah.
And that will give you the mean and median. As far as the mode goes, just find out which number is repeated the most, right? That's what the mode is. Do you guys want to do that one, or are you good?
I
I
pretty
think I'm good, yeah.
Number 7 says what? Determine whether the study is observational study or experiment. Okay, so it says, you want to read that one?
Obese adults are randomly divided into 2 groups. One group replaces 1 meal a day with vegetables. The other does cardio for 30 minutes a day. After 3 months, each group is weighed to compare weight loss.
Okay, so one of them is eating vegetables, the other one is working out. So they got 2 groups. So they say the study is an experiment because the researchers control one variable to determine the effect on the response variable. What's the response variable? Like weight loss, probably?
Yeah, I guess weight.
And the explanatory variable would be like the treatment, whether or not it's working out or diet.
Effective,
Those are
yeah.
the 2
Like
treatments.
eating vegetables is effective, or working out, yeah. Which is better?
Yeah, so like it's an experiment. Yeah, it's an experiment. Because they're actually putting people into two different groups and they're saying, hey, you do this and you do that. They're really experimenting with people. Now, an observational study would be if I went to a gym and I monitored 100 people and I said, and like on day one, and then 30 days later, day one, I weighed them, 100 people. And then 30 days later at the end of the month, I weighed them again. And then I said, all right, which one of you guys were on a diet? And which one of you guys were exercising? They were all at a gym, so I guess they were all exercising, but I guess that example sucks. But I didn't do anything, you know what I mean?
Yeah.
Like I can't do anything for an observational study. I just make observations. I just ask questions. I said, did you diet or not? I just ask them that. So I don't experiment. I just observe. And then 8, what is this? Left, right, left skewed. What is it asking? Which of the following is correct? It's comparing the mean and the mean and the median. So is the mean smaller or bigger on this one? Which one is smaller, the mean or the median would be what this is getting at. So I'll tell you guys if you're not sure or what. Forgot?
Yeah, I kind of forgot how to.
Yeah.
So for this one, the mean chases its tail. The mean chases its tail. The mean is like a cat, which chases its tail. A cat chases its tail, and it's a mean cat. So the mean is chasing to the left. It's running to the left. So the mean is smaller than median, which that's why it's E. The mean is smaller than median because the tail goes to the left. Therefore, the mean goes to the left. Y then, número 9, asks you to find the standard deviation. Oh, this one it says upload your work on Canvas. I see. So finding the standard deviation by hand, it's asking to do. Do you guys remember how to find the standard deviation of some numbers or no?
No.
For that, oh, I guess I'd have proof. I guess I could, oops, let's see. Well, go back to sheet 1, it's bigger. Let's say I had some numbers like 1, 7, 5, and 3, 4. If I had those numbers to find the standard deviation, all I would do was I would get the mean. So I would take these, what's the mean? It's down here, it's 4.25. So then I would do this. I would say that this equals to this number minus 4.25, and then I would do that for all of these numbers. So do you see what I did? I just did x minus 4.25. That's what I did here. And this is just x. And then, arrows are so big. And then I would just square that. I would just say that this equals to this value raised to the 2. Kind of hard with this big old thing, but you see, so what I'm doing here is what? X minus 4.25 raised to the 2. So and now all I got to do is add those up. So if I'm trying to find the sample standard deviation, what I would want to do is say that that equals to the square root of something. How do you find the sample standard deviation? Square root of the sum of all these numbers. So I just add up all these numbers. What's that?
Of each square
18.75.
deviation,
Yeah,
essentially.
it's 18. What?
You add up all the squared deviations, essentially.
Yeah, the squared. Yes, the squared deviations. I add up all the squared deviations, and then I divide that by n-1. So I can do, where'd it go? I can say that this is 18.75 divided by n-1 is like 3. So yeah, that's how I do it. That would be S, the sample standard deviation. It would be the square root of 18.75 divided by 3. I just did it on Excel. Square root, yeah. So this would be square root 18.75 divided by 3. 2.5. Which 2.5, if you go like this, you say equals standard deviation sample, and then you just go like this. It should give the answer 2.5. So 2.5 is correct. Sample standard deviation. So that's how you do that one. Should I talk more? You guys got good with that one or what?
No, yeah, I think I'm good with that one.
Yeah.
Okay, and then 10 says, oh, good one. Empirical rule. It says 95% of organs will be between what weights? About 95% of organs will be between what weights? Given that the weight of an organ in adult males has a bell-shaped distribution with a mean of 330 grams and a standard deviation of 40. So it's describing the distribution of stuff, right? It's the distribution of the weights of organs. So we kind of know everything about the organs, right? We could even say something like, oh, no, come on, man. Something like X is, how do you do approximately here? How can you get that squiggly line here? Approximately normally distributed with mean, what's the mean? 330?
Yeah.
Standard deviation of 40. So you could say something like that as far as the weights of the organs. And then you could do the empirical rule from there. Just apply the empirical rule. 95% of organs will be between what? For 95, wait, 95%. 90, because remember there was like 68%, and then there was like 95, and then there, what was it? What was the other one? 99.7. As far as the empirical rule went, there was 3 different cases, right? Case 1 was 68%, and that would be plus or minus 1 S. This was like, oh, ¿por qué? We found a typo. No, don't do it. No. What are you doing? It's not wanting me to do stuff here. Format cells text. So yeah, but anyways, this plus or minus 1S, this is plus or minus 2S, this is plus or minus 3S. So if you want to find 250 and 410, you have to take the mean and add 2 standard deviations and subtract 2 standard deviations, right? So for the 95%, you do that this equals to what? 330 minus 2 times what? Minus 2 times 40, right?
Yeah.
So you see how we get that? 330. In fact, kind of want to say 330 minus 2 times 40, and then say equals that. Nah, I didn't like it. It did not like it, lads. But yeah, 330 minus 80 is what? 240? 250? And then this one would be 330 plus 2 times 40, right? So that's 210 with 410. So yeah, that's how we get the answers. I don't know, is there any questions on that? That was for the 95% one.
Yeah, no, I got that.
For the 68%, just do one. Adam, do you get that or no?
Yeah, I understand that.
All right, cool. So that was for that one, number 10. B says, what percentage of organs weighs between 290 and then 370? So for that one, how would you guys do that?
290.
Would you have to find, I don't know, I'm just guessing, would you have to find the percentage that those are, like that those are in? So like
Yeah.
how it's
Yeah,
95%
exactly.
kind of, we would just find like the percentage that that's in.
Using what though? How would you find that percentage?
Using the mean? I don't know.
Are you saying to use like norm CDF or the empirical rule?
Oh, I was thinking the empirical rule.
Yeah, use the empirical rule, exactly. So you can kind of start at a center of 330, and then if you subtract 1 standard deviation, if I subtract 40, I go to 290. If I add 40, I get 370. If I go 2 standard deviations out, if I subtract 40 again, I go to what, 250?
Mm-hmm.
And then if I add 40, I go to like 410, right? If I subtract 40 again, I go to 210. And then I go to, if I add 40, I get to 450. So which one was it? 210.
250.
Oh, wow. Oh, it's saying 290 to 370. So we got it already. It's here.
I didn't even notice that. I thought it was
290 to 370. So that's 68%.
Mm-hmm.
The answer would be 68%, because that was when we only added it once.
And that's because it goes 68%, 95%, and then 99. Is it 99 point something, or is it just 99%?
99.7?
0.7, yeah, that's right.
99.7, I think. Yeah, this thing is hard to deal with. Yeah, 68, 95. 99.7, yeah. All right, so you good with that one or what?
Yeah.
Yeah. So what I did was I added and subtracted 1 standard deviation, then 2 standard deviations, then 3 standard deviations, and I tried to figure out what were the 2 numbers that matched the numbers that they gave me. And it turned out to be 290 and 370. So I said, oh, so then that was when I added and subtracted 1 standard deviation. So that had to be it. 11, what's the difference between a population and sample? It says a population is the entire group that is being studied, while a sample is a subset of the population that is being studied. Population is everything, sample is subset. That was your number 11. Number 12 was what? Or is that it? I think 12 was the last one. 12 was another question where it tries to find the average score on a test. So it says Marissa's calculus course attendance counts for 15%, Quizzes count for 10%. Exams count for 50%. Final exam counts for 25%. Marissa had 100% average for attendance, 93 for quizzes, 82 for exams, 85% on the final. Determine her score. So would you guys know how to do that?
It's like a weighted mean, right?
Yeah, it's a
So you
weighted mean.
Would you multiply like the percentage, how much like the attendance is 15% of the grade times 100?
Yeah. Yeah. Times 100.
Like kind of
so.
like the other problem we just did.
Yeah, it's kind of like the other problem. Yeah, just exactly the weights. Should we say weights, or should we say, yeah, whatever, weights and then score? The weights. What are the weights? 15 for attendance. Quizzes. Quizzes are 10. I'm gonna say 0.15. No, I didn't like it. It's formatted differently. If you're formatted like that, then I'm gonna leave. Forget you. Exams count for 50%. Final counts for 25. What else do we got? Is that it? So there's only 4 things. What are the scores? The scores that they got were, for Marissa, she had 100 for attendance. Okay. Attendance was good. 93 for quizzes. Was this quizzes? I mean, you got to be organized here. What else do we got? Tests and then finals, I'm guessing. She got an 85 on the final. What'd she get on the test?
82.
93? 93 or?
82.
Oh, 82? She got an 82 for exams, 85 on the final. So then now, yeah, just multiply these out. Really, if you just do like this, if you go like on Excel, you say equals this times this, it'll give you that answer. And then if you just scroll down or just double click here, double click and then it gives you that. And then you could say sum, they equals SUM, teaching you Excel, but you guys can do it on your calculator. Did you guys get that on your calculator? We should have statistics on Excel, huh? We should have a class where we teach it on Excel. Yeah.
Yeah, that'd probably be pretty good, actually.
Yeah. Since we already have everybody already has Excel pretty much. So that's like finding her score in the class. Her score is 86.55, which is correct.
Yeah.
Excel is the key to life. That's why I have these shells here. It's like Excel, different cells. See, get it? Cells, rows, and columns.
Yeah.
Organization, man. Organization. Okay, next one. We're done with that one. We got to go to test 2 now, right? You want to go to test 2? For test 2, we're not on we're not on my math lab. Let's close it. Let's see. How do I get to test 2? It would be somewhere out there over the rainbow. Test 2. Hold on, I'm on a different screen. Let me see. Quizzes. Test 2. So many different test 2s. How do we view this? Preview, maybe? So preview. So this is test 2. All right. Question number 1 says, the table lists the drinking habits of a group of college students. If a student is selected at random, find the probability of getting someone who is a man or a non-drinker. Round your answer to 3 decimal places. So we would do man. So I don't know. What do you guys think? How would you do this?
You would go to the man non-drinker, so 135.
Man, non-drinker, 135. Okay.
You just minimize this. And then would you divide 135 by the total, including that number? So it would be 402.
Okay. So you're doing 135 divided by the sum of 135 and 402, right?
Yeah,
Okay.
that's not it. Never mind.
The thing about 135 is that's the number of people who are male non-drinkers, the number of male non-drinkers. The question is asking the probability of getting someone who is a male or a non-drinker. I don't want the probability of getting someone who is a male and a non-drinker. That's what you gave me.
Yeah. I read that wrong.
A male and a non-drinker. So now what do you think? It says male or a non-drinker.
Sure. So would you do 187? Yeah, would you do 187 minus? No.
I would never do a 187, bro. No, I'm just kidding. Yeah, 187, then what?
I definitely know that you start with that 187 because that's all of the males.
Number of males. Yeah, that's great.
But
yeah, the number of males, 187. Okay, good. What else?
Well, we need to take the non-drinkers, but would we get rid of the 135 man? Sorry about that.
Yeah. That's right. Exactly. So you would add what? Oh, yeah, you get rid of the 135. So take all the non-drinkers, but get rid of 135. So it's 187 plus what?
187.
Yeah. Did you see that? It's 187 plus 187. That's who we're looking for. Those are all the people who are either male or non-drinker.
And then over the total. Okay.
Yeah. Yeah, so that over 402. Which, if you want to find that answer, oh yeah. Well. Let's see. Look, what do we have here? What do we have here? A calculator. Where's the calculator? How do I get a regular calculator and not a graphing calculator? What was it? 2 times 187 divided by what? 402?
Yeah.
93%. There's our calculator, folks. 93%. How do I go to like another screen? Do I hit Alt or something, or Control or Windows? How do I just like go to another screen? Like in a cool way. I know. Control Tab. Oh yeah, Control Tab. Okay, so where are we? Are we doing this? Okay, good. Control Tab will take me. Oh, duh! I could have just clicked up here with the tab with my mouse. All right. So, question 2 says, find the probabilities. What's it saying? You have a sample space S, and you got a set A, which is 9 through 13, and it says find the probability of A complements. What's the complement of A?
It's just everything that's not possible in A, right? So it'd be 6,
Yeah.
7, 14.
Exactly. So 6, 7, yeah, 14, 15, 16. Now how many is that? 2, 3, 4, 5. 5 things. 6, 7, 14, 15, 16. 5 things. So the probability of the complement of A would be 5 divided by what? 5 divided by what?
11?
Yeah, 5 divided by, is that how many things there are? 11? So then, yeah, it would just be 45%. Because there's 11 things between 6 and 16. There's 11 things. So 5 over 11, right?
Hmm.
Doesn't like the dots, does it? Okay. Good with that one? You good?
Yeah.
Yeah.
Okay, number 3 says, classify the following random variable according to whether it is discrete or continuous. The number of pills in an aspirin bottle is discrete.
Yeah.
Because you can count it. 1, 2, 3, 4. Discrete is things you can count.
Mm-hmm.
What about this? Is this discrete or continuous? Temperature, anything you can measure. Is measuring things and counting things is different, right?
Mm-hmm.
The things you measure would be height, weight, temperature, age, amount of money, amount of volume. Those are things you measure. Things you count, like 1, 2, 3, that's discrete. All right, so for this one, it says, can this be a probability distribution? Yes or no? Saying yes, and why is it saying yes?
The probabilities all add up to 1, right?
Exactly, the probabilities add up to 1, and none of the probabilities are
Over 1?
or negative, right?
Yeah.
None of the probabilities are greater than 1 or negative. So that's why that is a valid probability distribution. Number 6. Provide an appropriate response. What is this asking? Find the mean of the random variable and explain what your result means in context. If it's talking about a sandwich shop, where X represents the number of condiments used for a hamburger. What do you guys think about this one? Do you understand this one or no?
We go over this one. I'm just confused.
Should we go over this one?
Yeah, sure. It says, all right, so when I see this question, I understand it to mean that we have a probability distribution here, and I understand that probability distribution.
So we want to take the weighted mean again, I guess, right?
pretty much all you got to do is take the weighted mean, but yes, and then you want to explain it in context.
Yeah.
So all you do is take the weighted mean, and as I look at these numbers, it's around 1 would be like the center of gravity. So so let's say it's 1.2 is the weighted mean. In context, what that means is, on average, hamburgers have 1.2 condiments. That's it. On average, hamburgers have 1.2 condiments on them. And
Yeah, so
that's
the
it.
explaining is kind of the bigger thing there.
Yeah, explaining it's kind of hard. Finding it is a matter of doing what we did before. Just plug the data in to L1 and L2. Make sure you put the weights in L2. You do actually have to put the weights in L2. And those weights should add to 1. So yeah, I don't even know if do you want to plug that in your calculator or do it or no? Weights in L2, did I say that?
Yeah, I'll put it in.
I'm not sure how I know how to do this. I'm not sure if I know how to do this. Let's see, equals to mean, say average. I don't know if I know how to do this. What's the answer? Do we know it?
1.14.
1.14?
Yeah.
So I don't know how to do this apparently on Excel because I don't really use Excel, but I wish I knew how to do it on Excel, but I'll learn that later, I guess. On Google, a thing called Google. Mean. All right, well, just skip it now. You got what? 1 point what?
1.14.
And then like explaining it, remember you would say on average.
There's 1.14 condiments on a hamburger.
Yeah, good. All right, cool. Hold on 1 second. If I change this to text, it will allow me to put a decimal point after the 7. All right. What else? Okay, this is where we need to spend probably 5 to 10 minutes because these are hard. These questions can be pretty hard. Anybody know the theme of this question? Anybody know? It says, Mama Tempty bakes 6 pies a day that cost $2 each to produce. On 38% of the days, she sells only 2 pies. On 22% of the days, she sells 4 pies. On the remaining 40% of the days, she sells all 6. If she sells her pies for $4 each, what is her expected profit for a day's worth of pies? Okay, do you know the theme of this question? The theme would be expected value or expected profit, something like that, which is 6 point, maybe 1 or 2, I forget. Is it 6.2? Let's put 6.1 or 6.2. I forget what section it is, but it's something that I really love to put on tests. So not this question. This question's a little bit too hard. But what if I said this? Because this question's a little bit hard. I wouldn't put this question on the final, but I would put a similar question to it. So let's make up a question. Because yeah, this don't worry. This is too hard. Don't worry about this specific question. Let's say it's raining. Let's just say pores. How do you spell pores? Let's say heavy, moderate, light. Let's just say none. Let's say the question says something like the probability of rain is forecasted for June 12th to be heavy, moderate, light, or none at, oh crap, hold on. How do I make that into one cell? U or cell styles? No, not cell styles. Well, let me just do this. What I wanted to do is combine that into one cell, but it's not letting me. Oops. It's kind of hard with this big old thing, but oh well, do this. All right, the probability of rain is forecasted for June 12th to be heavy, moderate, light, or none at 0.1, 0.2, 0.08, what's that, 38? Respectively. See what I'm saying? The probability of rain is forecasted for June 12th to be heavy, moderate, light, or none at 0.1, 0.2, 0.08, 0.12, 0.5, respectively. 1, 2, 3, 4, 5, 1, 2, 3, 4. Oops, do I have one extra probability? That sucks. So I'll just make this 28. Are there only 4 cases? I think so. So there should be 4 probabilities, right? So we know the probability that it's going to rain tomorrow, right? Tomorrow's the 12th. So we know we have a 50% chance that it does not rain, right? None. The question is, now what's the question? We are selling, what are we selling? Drugs? No, I'm just kidding. We're selling Black Lives Matter t-shirts. If it rains heavy, we'll make 100. Moderate, we'll make 500. Light, we'll make, I mean, all this is, you know what to do with the question like this, right? Just plug it into lists and then just have it, that's it. That's all you got to do with questions like this. Now, the problem is that we need to do something where we pay, right?
Yeah, there's the minus part of it too.
Yeah, so how can we make this problem into something that, let's say this, we paid for a venue, how much? $1,000 for June 11th, right? Or what's tomorrow, the 12th? We paid $1,000 for tomorrow. You understand? We paid $1,000. So we're invested. But rain could mess us up, right? So if it rains heavy, we make $100. If it's moderate, we'll make 500. If it's light, we'll make 1,000, right? If it's none, we'll make, or let's say we make 2,500. Let's just say here we only make 800 or something. So there's the question. Now it says, now the question would be, I hate this thing's too big. What is our expected profit for the event? I'm just making a question up. Would you know how to do that one or no? Or do you want me to do it or no?
I just have like a guess. I think, would you take like kind of like the like grade average? Would you do like 100 for 0.1 and then like put it in the list like L1, L2, so 100 in L1 and then 0.1 in L2, and then 500 in L1, 0.28 in L2, 800 in L1, 0.12 in L2, 2,500 in L1, and then 0.5 in L2, and then just when you get that value, say it's 2,000, just subtract the 1,000 because that's what you paid for the venue.
I think that sounds good. Good idea. Yeah, it sounds like a good idea. So you were saying to put
Pretty much like match those values.
0.1, 0.28, 0.112, 0.5, and then you would put like, what would you put here? 100?
Yeah, 100, 500, 800,
800,
and then 2,500.
500. And then you would find the mean, right?
Yeah. And then just subtract 1,000.
Yeah.
What's the mean? Mean would be equal to, did you get it yet or no?
No, I didn't even plug it in. I was just following. All right, I got 0.3835.
Wait, 0.3835. Wait, after you subtract it or no?
No, not after I subtracted.
So what do I divide the sum by again? What are the weights? And the calculator.
Yeah, when I put it in the calculator, I just put like that first column in L1, second column in L2, and then I our stats, and I got 0.3835, 0.3836 if it's rounded.
I don't think you did it right because you have to put the weights in L2. 0.1, 0.28, 0.12, and 0.5 need to be in L2. The weights always need to be seconds.
I see. I think I did. Yeah, I did that wrong. I put the weights in L1.
So just when you do one bar stat, you don't need to switch L1 and L2.
You just switch it like frequency, do L1 now. And
Yeah. Or if you're not using the wizard, you could just do one bar stats L2, comma L1.
Now I got 1,496. Yeah.
So then the expected profit is 1496 minus 1,000, right?
Mhm.
Like you said,
$496.
496. That's their expected profit on the event. Hold on one second. They're gonna make money. Selling those t-shirts, man. All right, so that's like an expected value question. How do I go back to that? Is this binomial? Next question says, is this binomial? It says, decide whether this experiment is binomial. You draw a marble 1,000 times from a bag with 3 colors of marbles. The random variable represents the color of marble that is drawn. What do you think? Is that a binomial random variable?
No, right? The outcomes are not like it's not equal probability for each. It doesn't say the probability for each color.
Yeah, it's not binomial. You're correct. What's the rationale that you use, though? I'm not sure why you said it. Said the probability is not the same for the different colors.
Yeah, it's not as the same, not equal probability.
That's pretty interesting. The random variable represents the color of marble that is drawn. Well, there are 3 different colors. An easier way to say it would be, what you're saying is true. You'd have to explain it more.
Okay.
But there are 3 colors.
So it's
It says there's 3 colors. So there's not 2 options, right?
yeah. So that would be the main.
That'd be an easier thing to cite why it is not binomial, is just to say there's not 2 options in order to be binomial. There needs to only be 2. There needs to be success, failure. Now in this one, it's not defining success and failure because it's just saying that a color, they're just noting the color, and there's more than 2 colors. So like the variable is going to be this: white, black, green, green, black, white, 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 black, white, green, white, green, white, green, black, green, black. Every time you pull a marble out, you're either going to get white, green, or black. I'm making those colors up, but that's why it's not binomial. That's an easier way to describe it. Something like there are more than 2 outcomes. And then number 9, you could say, this testing a cough suppressant using 340 people to determine if it is effective. The random variable represents the number of people who find the cough suppressant to be effective. I would say yes.
Yeah, because it's either they don't find it effective or they do.
Yeah, 2 outcomes. Constant probability. Test needs to be people need to be chosen. Don't worry about saying this. I'm just saying that some of the requirements to be binomial, but it doesn't ask for that. It just says, is it binomial? Yes or no. So this one says, what's it trying to do here? According to the government data, the probability that an adult was never in a museum is 15%. In a random survey of 10 adults, what is the probability that at least 7 were in a museum? I don't like this one. I think I messed up on this one because it says in a museum. And this one says never in a museum. So that's like a typo or a trick. It's either a typo or a trick, depending on who your teacher is and whether or not they want to trick you. For me, it was a typo. I didn't mean to do it like that, but the probability never in museum equals to 0.15. Probability in a museum, therefore, equals 0.85, right? If there's a 15% chance of never being in a museum, that means there has to be 85% chance of being in a museum. So from there, what are we trying to do? There's 10 adults, so it looks like n equals 10. It looks binomial to me. They're either in it or not. I'm trying to find probability that x equals to 7. No. At least 7? What's the probability that at least 7 were in a museum? At least 7. Okay, so x has to be at least greater than or equal to 7, right? So we have to say 1 minus binom PDF. CDF, huh? CDF. Or I could do this, 1 minus the probability that x is less than or equal to 6, right? Greater than or equal to 7, the complement of that is 6 or fewer, right? 6 or fewer, right? So that's how we would kind of think about that. And then from there, we would just say that this equals to 1 minus binom CDF of like 10. Remember NPX, so 10. At least 7 were in a museum, so 0.85. And then 6, right? So that's how we would do it. It's not liking me for that. That sucks. Just lost everything. Won't be able to go back, but yeah. 1 minus oh my. Okay. Binom CDF 10.856. Yeah. Which I don't know if we have that ability here, but look at that. Maybe we do on Excel. I never tried it. I'm learning new things actually here. You've entered too few arguments for this function. I need to plug in the number, S, trials, probability, and then cumulative. So here I need to probably put 1. Put the number S, I need to put 6. The number of trials, I need to put 10. Probability. Oh, I think that worked. I don't know. What'd you guys get?
1 minus it. 0.95003, so 0.95.
I got that same.
That's good.
So then would you say, like, if we in the sentence or whatever, would you say at least 95, or what is probably, so yeah, the probabilities, or there's a 95% probability that at least 7 people were in the museum.
Yeah. Or maybe 95%. Yeah, that works. 95% chance. I'd probably say the word chance. Or, yeah. Because if you said, yeah, the word probability, I would say the probability that at least 7 were in a museum is 0.95, I would say. If I'm going to use the word probability. Or if I want to use the number 0.95, I have to kind of use it the right way. But anyway, yeah, I'm just being too nitpicky. But yeah, you're right. You're right. So what else? 11? Do you want to read it? Do you want to, what's this one? Can you read it?
In a recent survey, 60% of the community favored building a health center in their neighborhood. If 14 citizens are chosen, find the probability that exactly 5 of them favored the building of the health center.
So how would you do that one?
Sit with binomial PDF then, right?
Yeah, I would do binomial PDF because it says exactly 5, right?
Okay.
Yeah. So on a calculator, I'd say binomial PDF, and then I'd plug in like 10, comma what? 0.6, comma 14 citizens are chosen. Maybe I should plug in 14, right? So NP, and then how many we're looking for? Exactly 5. I'd plug something like that on a calculator. On Excel, I'd put binomial PDF, or what would I do? Binomial.dist. I put 5. On Excel, we do it differently. 5, 14.6, and 0 for false. Did you get that? Because there's 14 that we chose. N equals 14.
Yeah.
Right? You got it? Cool. How about you, Jack? Were you able to get it?
I got 0.0408.
Yeah, that's what we got. About 12. 12, 13, 14. 12, 13, 14. Can you read it?
Yeah, assume that male and female births are equally likely and that the birth of any child does not affect the probability of the gender of any other children. Find the probability at most 3 girls and 10 births. At most. So I guess there would be binomial CDF because it says at most again.
I think so, yeah.
Then,
Can we say that the probability of find the probability of at most 3 girls? Okay, it's probability of a girl, or G, equals to 0.5, right? Does it give us the probability? No, then it's 0.5. Probability of a girl when you have a kid, 0.5, either a boy or girl.
and in 10 births, so 3.
At most 3 girls and 10 births. So we want the probability that, let's say X equals to a random variable number of girls from 10 births. So we want the probability. Oh crap, I should have. Random variables are capitalized. Probability that X is at most 3, less than or equal to 3. So that's just, yeah, we could try binom CDF, right? Do you guys know how to plug that in or no?
Yeah.
On a calculator? At most 3 girls and 10 births. So then we would just plug in 10, comma, 0.5, comma 3. At most 3 girls, right? So what do you guys get?
Got 0.1718.
Binom.dist 3, comma 10, comma 0.5. I'm learning new stuff here. 0.172?
Yeah,
You got that?
0.172 rounded, yeah.
All right, cool. Next one, can you read it?
Yes, steel bolts. Steel bolts need to be produced to have a length of 25 centimeters. The manufacturing process isn't exact, but the lengths are normally distributed with a mean of 25 centimeters and a standard deviation of 0.5 centimeters. If the lengths of the bolts are not between 24.7 and 25.3, they will be thrown out. So the probability that a screw will be accepted. Okay.
All right, focus on A first.
Yeah, I'm just trying to process what you're saying too.
Yeah. A screw will be accepted when?
So
If
it
it's
needs between 24.7 and 25.3.
And also, the lengths are normally distributed with mean 25 and standard deviation 0.5. So can't we just say that this equals to norm CDF, right? 24.7 comma 25.3 comma, what's the mean? 25 standard deviation 0.5. Can't we just do that? What do you guys think? Is that how you would do it? Normal distribution. Let's see how this works. X mean standard deviation cumulative. Ooh. Norm dot distribution does not work so well here. On Excel, you're kind of screwed. You have to do 25.3 comma mean standard deviation cumulative. You guys get it?
I'm still just putting it in. 0.7. 0.4515.
Yeah, that's what I got using Excel.
Yeah.
Yeah, I just got that.
Yep. On the TI-84, of course, I'm showing the TI-84 commands. Of course. I don't have my TI-84 out, but that's why I'm writing it down. How you would do it on a TI-84. Okay, next one. 14. Can you read that one? Is this the last one? Yep. Wait. I don't think we did a B. Interpret the probability that you found in A. B. How would you interpret that?
There's a point. There's a.
I want you to use the word proportion because I like that word too, not just the word probability.
So the proportion, the proportion.
That a screw will be accepted.
Not the proportion that a screw will be accepted, but the proportion of screws.
Yeah, the proportion that will be accepted at this point is 0.45.
Oh, crap. What did I do? The proportion of screws that will be accepted is 0.45. That's it. Good. I don't know if you want to do C. Do you want to do C or no?
Wait, what's he asking? If the order comes in for... Oh yeah, can we do that? I was kind of confused how to do that. I'm not really sure how I did it on the test or if I even got it.
What would you put in for that?
For C, what I would do, an order comes in for 1,000 screws. How many screws must you produce to guarantee that you will have 1,000 screws? I would say, well, 45% of them are accepted. So I say 0.4515x equals to 1,000. So 45.15% of some bigger amount of screws equals to a smaller amount of screws, which is 1,000. I would do that.
And then divide, I guess.
I would say equals, yeah, 1,000 divided by 0.451. Actually, I would do divided by this. And that would give me the exacter answer. But yeah, what's happening? I would say you need what is it? You need to make 2,215 screws. That's what I would say. Because if you multiply 45% of 2,215, guess what you get? 1,000, right? So that's like a percentage question. Kind of came out of the blue. That's why it was extra credit. It's not really a statistics thing. It's more like a different type of thing. So then 14 says, do you want to read it? Let's see. Go for it.
A pizza delivery company has a guarantee that if the pizza isn't delivered in 45 minutes, the pizza is free. The time it takes to deliver a pizza is normally distributed with a mean 35 minutes and a standard deviation of 6 minutes. What is the probability that a pizza will be delivered late?
Okay. What do you think about that one? So what's the probability that a pizza will be delivered late? What does it mean by that? If it did, okay, it says if it's not delivered in 45 minutes, the pizza is free. So when, by late, does it mean that it takes 45 minutes or longer? That's what I'm guessing, because it really doesn't define late, does it? Not that, I mean, I didn't really read it much, but
Yeah, so I would assume that like late is after 45 minutes, so they don't get it for free.
yeah. So then basically we're trying to find, based off of that, I would say that we're trying to find the probability the pizza is late equals to the probability that X is greater than or equal to 45, which is norm CDF 45, 999, comma mean 35, comma 6. That's it. 45 or longer, 45 minutes or longer, so 45 to 99, 45 and above, mean standard deviation, mean of 35, standard deviation of 6. That's it. That's all I would do for that one. On Excel, I would do norm.dist. It wants X, it wants 45. It wants a mean, 35. doing this on Excel. Well, I would want 1 minus that though. 1 minus that. On Excel, I would do it like that. We're getting 4.8%. Is that what you guys got or no? Or are you still thinking, learning like?
Yeah, I got 4.8.
Cool. You ready for part B or what?
Yeah.
For B, notice that on this one I'm looking for a probability. I'm looking for a probability, and on part B I'm looking for a value. When I'm looking for a probability, I use norm CDF. When I'm looking for a value, I use inverse norm. For norm CDF, it's always lower, upper, mean, standard deviation. Running out of room, but for inverse norm, it's always area to left, and then mean, standard deviation. So on this one, I'm looking for a value. So I'm going to use inverse normal. The question says, what does it say? Pizza company wants the probability that they have to give a pizza away for free to only be 3%. What should they change the time to instead of 45 minutes? So we want it to be we want the probability of being more than or equal to x to be 0.03. I'm getting tired, man. We want the probability of being more than or equal to x to be 0.03, right? I can't draw anything, right? I can't draw like. Problem is, I wish I can draw like a normal curve. I can, but I'd have to open up StatCrunch or something. But imagine a normal curve that is shaded on the right side of the normal curve. It's shaded above. Why is it shaded above? Because it's longer times. These are longer times, so they're to the right. It's like right-tailed. So shaded to the right needs to be 0.03. So basically the area to the left, from that we kind of, if you look at that picture, we do the area to the left is 0.97 because the area to the right is 3%. Therefore the area to the left is 97%. Uh-oh. Doesn't like something. Oh man, I think it like thinks that it's a formula still. Let me get rid of that thing. Area to the left is 0.97. So we do inverse on a TI-84, inverse norm 0.97, and then mean and standard deviation 35, 6. That's it. That's all you do.
46.287.4 or 285.
So you got I've never done this before. Let's try it. Probability 0.97, 35, 6, 46, 46 minutes, 46.28 minutes, right? That's what you got, 46.28?
Yeah. 46.28.
So we need to increase it from 45 minutes to 46, I would say 47 minutes. If I was working there, I'd be like, hey, just make it a little bit longer. Keep it safe, right?
Yeah. And then looking.
Should we do test 3, or what do you guys want to do?
Yeah, can we just start test 3?
Sure. You guys got more time in you?
Yeah, I got a bit.
All right, cool. Let's see. Quizzes. Test 3. Where was I at? Preview? Number 1. All right, do you want to read it?
Ages of coronavirus deaths are normally distributed with a mean of 64.38 years and a standard deviation of 14.26 years. What's the probability that a random death was from a person who was younger than 55 years?
So we have, it's normally distributed, and we have everything. We have the mean and we have the standard deviation, right? And it's asking for a probability. So all we got to do is norm CDF on A. B is the one that's trickier. On B, it says you have 20 deaths. This one says from a person, okay? This one says 20 people. You see the difference between A and B? This is regular normal distributions. This is sampling distributions. In other words, in A, it's trying to find the probability that X is younger than 55. But in B, it's trying to find the probability that X bar. How can I draw X bar here? I don't know. Actually. Do I have math type here or no? Do you not have math type here? Well, whatever, I'm just gonna say X bar, right? X and X bar, the sample mean, younger than 55. So that's the difference between A and B. So for this, I'm just gonna say norm CDF, just straight up. Negative 99999, comma 55, comma. Mean and standard deviation 64.38. 14.26, right? That's it. Which equals to norm. If you guys want to plug it in, we can do it. Did you guys get that?
Yeah, I got that.
Cool.
Mm-hmm.
On part B, since it's an average, we're trying to find the probability that the average, right? Where does it say average? The mean. Find the probability that the mean of 20 deaths, so it's X bar. So when we do it, we actually have do the same exact thing, actually, believe it or not. But just one slight difference, that we have to divide by the square root of 20. And that's it. That's the only difference on B. You divide by the square root of n, square root of 20. So when I go in here, all I gotta do is say divided by, see if this works, square root of 20. Oh, why not? Works. Make sense or what?
Yeah, is that the entire norm CDF divided by square root 20, right? Or is it just the
No,
last?
just this last part.
Okay.
Just the 14.
Okay.
14.26. That's it.
Yeah.
'Cause that's the standard error.
Yeah.
And here,
Because it's
in
the
part-
TI minute.
and here we have the standard deviation. We have, I guess I should say, we have sigma, or I could say standard deviation of 14.26. Here I should say standard error of 14.26 divided by square root of 20. See? Standard deviation, standard error. Oops. So the square root of 20, it's sort of attached to the 14.26, right? Excel is kind of nice. I like how it's so organized. Although Word would probably be good too. But Excel does more calculations. As you can tell, I'm able to get like, it's pretty amazing how it has like everything that a TI-8 does. All right, let's see. Did we get them both? Did you guys get them both or what? A and B? Are you good or what?
Yeah, I get that.
Cool. So number 2. Can you read it? Hold on.
According to a survey in a country, 17% of adults do not own a credit card. Suppose a simple random sample of 800 adults is obtained. What is the probability that in a random sample of 900 adults, more than 20% do not own a credit card?
This is probably one of the harder questions because it has to do with the proportion. I love this question because it I don't know why I love it, because it's hard. I like the hard questions. Sad, huh? No. I don't know. Let's see. What does it say? What's the probability? We're looking for a probability. So we're probably going to do norm CDF or binom PDF, but probably not binom PDF. But let's see. What's the probability that in a random sample of 900 adults, so we have a big sample size, so it's sort of like chapter, man, I forgot the chapters, 8, chapter 8, sampling distributions, because we have a big sample, right? This is like where real inferential statistics happens in chapter 8. In the last test we did like chapter 7, we were just doing like regular norm CDF for a single person, but now this is for like 900 people. And we're trying to find that what's the probability that 20% of them don't own a credit card, the 20% of the 900. Okay, we're trying to find the probability that 20% do not own a credit card of these 900. So really I'm trying to find, we have A and B, so I'll say A. So let me see if I can make room here. Let me do that. Try this. So for A, You understand we're trying to find the probability that 20% do not own a credit card now. Should I leave it as a 20% or like 0.2, or should I find 20% of 900 and use a number like whatever 20% of 900 is like 18 or 180? Should I use 180 and say what's the probability that 180 or more do not own a credit card, or should I leave it as 0.2? That's one question you want to ask. If I convert it to 180, then I'm going to go to binomial CDF. If I leave it as the 20%, then I'm going to stay in the normal distribution. Now, we do have like 17% as a number up here. It says 17% of adults do not own a credit card. That's going to be sort of our mu, the mean of the sampling distribution. And the standard, we don't have any standard deviation, notice. There's no standard deviation. But I want to find the probability that p hat is what? What's it say? 20, more than 20%. So greater than 0.2. That's what I'm looking for. The probability that p hat is greater than 0.2. What's the probability that p hat is greater than 0.2? P hat. 20% from a sample of 900. So the way I do that is I'm going to say that this equals to norm CDF, but I'm going to plug, I'm going to plug in 0.2 comma 999. I'm going to put 0.17 as the mean, and then here's the hard part, square root 0.17, 1 minus 0.17 divided by 900. That's like what I'll plug into norm CDF, you know? Make a little bit of room. Or actually I could do this. Just 3. That works. So all I'm doing is norm CDF of a proportion.
Yeah.
It's sort of confusing, but cool to me, kind of like a puzzle. It's enigmatic. Does that even work? Is that even a word? I don't even know.
I think so.
It's cool. It's enigmatic because you have a mean, but it's a proportion question. But it makes sense that you have a mean because there's 900 people. But it's actually odd that the mean is a percentage. The mean is a percentage.
Yeah.
That's kind of normal, I guess. On average, 17% of people do not own a credit card. So if I take samples, I would expect 17% of them to not own a credit card. That's what that means, that the average is 17%. Yeah, so any questions on any of that?
I think I get that one. 7.
I don't know if that's gonna work. But Did you get the opposite of that, the complement of that, or no? Did you get it or no?
The complement?
Or did you get the answer?
Yeah, 0.00828.
Wow,
329.
that's pretty good, man. Oh yeah, right. I had to do the complement because for some reasons Excel works differently, but so yeah, that's a good one. And then it says, would it be unusual for a random sample of 900 adults to result in 135 or fewer who do not own a credit card? I guess for that we just do the same thing, but now we go left-tailed, right?
Yeah.
We just go left-tailed. And 135, we actually have to say p hat equals 1/3. We have to calculate that. And then we could say, or not, you don't have to calculate it. You could say the probability that p hat is less than 135 over 900, just leave the fraction. Norms CDF, negative 999, comma, 135 divided by 900. But this is, oh yeah, 0.17 square root, blah, 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 blah. Well, I should leave the 0.17. Same thing. Keep using the 0.17 for the standard error, because that's what's assumed to be true. So yeah, that's it. So that, yeah. Guess it's just the same thing as the other one, Control C, Control V, except I should change something. Negative 9s. I'll have to put in 135 over 900, and I'll have to get rid of the 1 minus over here. So did you get that? Whoa, 0? Did you get 0? Why'd I get 0?
Yeah.
A really small probability. Something pretty small. So then you would say, yes, it's unusual. Since the probability is less. Like that? Or did you get something different than 0? Let me see. What's 135? 15%. Hold on. 15%. Does this make sense? Something may not make sense. I don't know. 17, 18, 19, 20. No, can't be 0. Because 135 over 900 is 15%, and that's closer to 17 than 20% is. So the probability should be smaller or bigger than 0.00829, right? Could this be wrong? Let me think. The mean is no longer in there. The mean is not in here anywhere. We're supposed to put the mean second. So the mean should be second, should be 0.17, comma. I plugged it in totally wrong here. That's why it's coming out weird. 135 over 900. I plugged it in wrong. Mean, standard deviation, cumulative. This looks right. Yeah, 0.0. That makes more sense because that's a bigger probability. It has to be bigger because 15% is closer to the mean than 20% was. Did you get that? 0.0551? Okay. Yeah, you can practice this later or whatever, but
Yeah.
this is just stuff that you need to know how to do, you know? But the 15%, I don't need that there necessarily, but 3. You want to keep going? You want to try this or what? Just let me know when you're tired. Go ahead and read that if you want.
You are trying to find the probability that a sample of dogs has a mean weight greater than 50 pounds. Assume that dogs have a weight that is normally distributed with some mean and standard deviation. What would have a smaller probability? The mean of 20 dogs being more than 60 or the mean of 100 dogs being more than 60? Explain why.
So conceptual. One thing that I want to point out is that it says some mean and standard deviation. Assume that dogs have a weight that is normally distributed with some mean and standard deviation. We don't know the mean and standard deviation. I made this question purposefully so that you don't calculate anything. I wanted you to just think about this and come up with the answer conceptually. I did not want you to calculate anything. All I did was give you, I don't even know, let's see. Sample of dogs has a mean. You're trying to find the probability that a sample of dogs has a mean weight greater than 50. What's the probability that the mean weight will be greater than 50? Okay. Greater than 50, it's a right-tailed test. Do you see that? Because it says greater than 50. So imagine a normal curve, and then you have 50 somewhere, and you're shading to the right. I wanted you to think about the following concept. What concept am I trying to get at? What would have, let's see. What would have a smaller probability? The mean of 20 dogs being more than 60, or the mean of 100 dogs being more than 60? Explain why for full credit. I would say, yeah, what would you say, Adam?
I would say that the mean of 20 dogs being more than 60 would have a smaller probability because it's like if there's outliers with those 20 dogs, it'll throw off the mean weight more so than if there's 100 dogs and there's an outlier, the other 99 dogs will balance out the weight.
Okay. Let me see. So you're saying it's so what are you saying, Caleb? Let me rephrase. Yeah, go for it.
I would say that the smaller probability would be the mean of 20 dogs being more than 60.
So you're saying probability 20 dogs have a mean greater than 60, smaller, right?
Yeah, smaller than the 100 being more than 60.
Probability 100 dogs have a mean greater than 60. That's what you're saying?
Yeah.
So 20 dogs are less likely to have a mean greater than 60 is what you're saying.
Yeah.
And because with 20 dogs, if you have an outlier, no, you say if there's 100 dogs and you had an outlier, the outlier wouldn't
really affect it as
wouldn't
much.
Wouldn't count as much.
Yeah.
So the means would be closer towards the center with the 100, right?
Yeah.
So the likelihood that a mean is closer to the center is higher for the 100 dogs, right?
Mm-hmm.
Yeah.
That's true. That's true.
And that
You're
could
right.
actually, yeah. So that would actually mean that like those 100 dogs would more likely be at like 50 pounds since that's the mean weight. But maybe what I'm saying is with the outliers, maybe that goes in the smaller dogs, I mean the 20 dogs' favor, because that's what could make them higher than the mean weight. If there's a dog that say weighs 90 pounds, then that could make the mean weight go more towards 60. Whereas with the 100 dogs, it's probably going to be 50.
So wouldn't you say there are more dogs from the 20? There are more means that are bigger?
Yeah. No, yeah. Now that I looked at it in that way, I kind of like flipped it. I kind of flipped my answer because an outlier would actually make the dog weigh more than, make it more towards 60.
An outlier would affect the 20 dogs more than the 100, right?
Yeah, exactly.
So then there would be more means greater than 60 for the 20 dogs,
Yeah.
making that probability bigger, right?
Yeah.
Yeah, so let's see. Let's take the smaller. So what would have a smaller probability? We'll say 100 dogs are less likely to have a mean greater than 60 since their means are less, like you said, affected by outliers. They are also closer to the mean, 50, right? Why are they closer to the mean? Because sample size is bigger. So you have more data. It's more accurate. You're more accurate because you have more data. Therefore, the mean should be closer to the true mean of 50. But yeah. What would have a smaller? I guess we didn't answer the question. So 100 dogs would have a smaller probability. Right? All right, so good. Kind of conceptual question. Numero cuatro. Find the critical value for a 90% confidence interval. What would you do for that? Did you guys forget about confidence intervals?
A little bit.
So for confidence intervals, you just gotta do E plus, so like for the lower bound, it's E minus T star times S over square root of N. For the upper bound, it's E plus T star times S over square root of N. I'm using T because I don't have sigma. In this question, I don't have sigma. I just have a bunch of data. So in this question, I'd have to find X bar and S, right? We don't have that stuff. We have to find X bar and S from the data set. You find X bar and S, and then, but as far as this question, as far as finding the critical value for part A, to find the critical value, you're just going to do inverse T 0.0 5. That's it. Oh, actually, I need a degree of freedom, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's 3, 6, 9, yeah, 10. So I'm going to put like 9. Degree of freedom. That's it. That's how I find the critical value. That's called T star. T star equals. Let's see if this has it. T dot INV. Left-tailed inverse of the student's T distribution. 0.05. Wow. Look at that. Great. So that's how you do that. Then B, that's the critical value. So for part B, moving on to the next question, it says, what's the margin of error for the 90% confidence interval for the mean? So for the margin of error, I gotta say that E equals to T star times S over square root of N. T star times S over square root of N. So it's just equal to 1.833 times S. What's S? Is that given somewhere? Oh, I gotta find it. I gotta plug that data in and find it. So you can actually say 3120, 1210, 840, 668, 790, 1762, 3200, 2010. I love Excel. Don't have to mess with the calculator. 3143, 1228, because I can get X bar and S. This equals to the average. Sample standard deviation. You would do 1 bar stats. I don't know if this has 1 bar stats, does it? Maybe it does. I think here you say it's the dev and then dot sample. So there you go. Wait, what? Can that be right? I guess that can be right, maybe. Oh, there we go. So then I would just do 1053.408 divided by square root. Uh-oh. 10. I think the sample size was 10. Uh-oh, I'm running out of room here. But yeah, that's it. 1.833. This is how you find the margin of error. Times that divided by square root of 10. That's it. That's your margin of error. So for part C, it's probably saying find the confidence interval. So let's say lower. All I would do is say equals to X bar 19.45 minus margin of error 610.60. That's how I would get the lower. For the upper, same thing. Just add, right? So that's how you find the confidence interval. That's it. You have to do X bar as a point estimate, and then you subtract the margin of error, and then you add the margin of error. And there you have it. That's how you get it. So yeah, that's what that was asking. It was saying find the actual confidence interval. If we want to make a confidence interval more narrow or smaller, we should increase the sample size. What do you think about that?
False.
Huh?
False.
Let me see if we want to make a confidence interval more narrow.
To make it more accurate.
We should
What's
increase.
happening.
We should increase the sample size.
Shouldn't we increase so we have more information so it will be more accurate?
Yeah, so it'll be more narrow, right?
Yeah.
So true?
Yeah.
Yeah, I think so.
Yeah, true. That's true, because if we increase the sample size, it gets more narrow, right?
Yeah.
It
It's gonna
does
be
get more,
more accurate.
because as you divide by n, yeah, as you divide by n, the margin of error for, here's the margin of error formula. As you divide by n, the margin of error gets smaller because you're dividing by a bigger number. Yeah. So yeah, we say true. True on that one for sure. You make it more narrow as you increase the sample size. That's good. Number 8, for a 99% confidence interval, find the critical value. So this one has to do with a proportion, it looks like. So when I find the critical value, it's not going to be T star, it's going to be Z star. Because this would be a normal distribution. Although on this question, we use T star because it was a T distribution, because it dealt with the mean, you know. On this question, number 8, it deals with the proportion. So it's a normal distribution. So the critical value for a 99% confidence interval, I would just say Z star. I'd call it Z star this time, but the star should be a subscript. I would just do like inverse norm 0.005 for that. That's it. That's how you find the critical value in that. Since it's a 99%er, that gives us 1% in the tails, so 0.5% on each tail. And then just round that. It's gonna be norm dot inverse, and then all I gotta do is plug in like 0.005. I wonder if I can just plug that in. No, it wants me to plug in comma 0, comma 1. Okay, if you insist. There you go. There's your critical value. And then for 9, it says for a 99% confidence interval, find the margin of error. Now for this margin of error, it's going to be equal to Z star square root P1 minus P over N, I think. Or is it P hat? It's a confidence interval. So it's got to be P hat. That P right there is supposed to be P hat. Because we're in the confidence interval chapter. So we don't know P. Because we're trying to estimate P. So all we have is P hat. It says in a survey of 1,016 adults, they asked, when you retire, do you think you will have enough money? Of the 1,016, 565 said they were worried about not having enough money. Therefore, the only thing we have is P hat. 1,016 divided by, or 565 divided by 1,016. That's all we got. So I don't know, I don't have a hat symbol here, but how can I maybe do something like that? It kind of sucks, but I don't want to type the word hat. Do I have P hat somewhere? I don't know. Because I don't have math type on this thing. I don't have any good symbols, I don't think, here. But anyways, yeah, that's the margin of error there. And that's it. That's how you do that one. So you just use this 2.57 thing, plug in the square root. That's it. And then we don't have the answer, so we can't really. To find the confidence interval, just do like this. Lower equals to p hat minus e, and then upper equals to p hat plus e. That's all you do for that next part. When it says construct the 99% confidence interval, just do that. And then for 11, 12, 13, 14, 15, 16, 17, jeez. What the heck? How are there really that many questions here? I guess there's a lot of parts to some of these, right? Some of them have just multiple
like the
parts.
same question, just like
Yeah.
you know, like all the hypothesis testing.
Oh my gosh, I'm too tired for this stuff.
Yeah, we don't need to do like, you know, stuff.
I'm too tired, bro. You have any other ones you want me to do before I leave? Any last minute questions on anything?
No, I think like the rest are pretty similar to those for me.
Yeah. Because it's pretty much just like what we
Yeah,
did.
it's the same stuff again, I think.
Yeah. Yeah. All this stuff is newer to you. This is hypothesis test.
Yeah, it's a little
Like
bit
the-
more in the head.
Yeah.
Fresh.
Yeah, writing the Nolan alternative, the p-value, the test statistic, and the conclusion.
Yeah, it's like pretty similar to what we did. A lot of the stuff that was from the last test. So hopefully, it should
Yeah.
be.
Do the easy method on that stuff. Just do t-test or one prop t-test, z-test, or just do that stuff, you know? Don't do the hard method anymore.
Yeah.
Just do the easy method. Yeah. This stuff, there's videos on already, right? We don't need to redo this stuff.
No, yeah, I think there's a video for both of these tests, pretty much.
Yeah. So now we're good. Good luck.
Yeah, thank you. Thank you so much for this.
Yeah, for sure. You're welcome. Have a good weekend.
Yep, see you
All right, later, man.
later.
See you on Monday for the test.
See you.